recursive function may need to keep track of its progress by adding or removing elements from a data structure, such as a list or a stack. For example, a recursive function might add an element to a list each time it calls itself, and then remove the element when it returns. This can be used to keep track of the state of the recursion and to ensure that it terminates correctly. Another reason to add or remove elements in a recursive function is to implement a search or traversal algorithm, such as depth-first search or breadth-first search. In these cases, the recursive function might add elements to a list or stack in order to keep track of the nodes that it needs to visit, and then remove them as they are processed. Overall, the use of adding and removing elements in a recursive function depends on the specific problem being solved and the approach being taken to solve it. In recursion, it is often necessary to make a choice at each step about which path to take or which element to process next. This choice is often based on the specific problem being solved and the approach being taken to solve it. For example, suppose you are trying to find a specific element in a list using a recursive function. One approach might be to split the list in half at each step, and then recursively search the left and right halves. In this case, you would need to choose one half of the list to search and not the other at each step. Alternatively, you might choose to process one element at a time, moving from the beginning to the end of the list. In this case, you would pick one element to process and then remove it from the list before making the next recursive call. Overall, the choice of which element to pick or not pick in a recursive function depends on the specific problem being solved and the approach being taken to solve it.